Hello, Math Studies students. This is the last section of this chapter. We're going to talk about normals to a curve. Okay, so a normal to a curve is a line that is perpendicular to a tangent at a point of contact. So a tangent line, we already know, is this line that touches the curve at one point. So our normal is a line that's perpendicular. So there's our perpendicular line. All right? So, and we've learned that in Algebra 1, right? So the slope of a perpendicular line is the negative reciprocal. So basically we know the derivative gives us a slope. So the negative of the derivative, the negative of the derivative reciprocal is going to give us our normal. Okay, so this is basically negative 1 over the derivative, and that will give us our normal slope. Okay, so let's do the first example, and this example is in your textbook on page 580. Okay, find the equation of the normal for f of x equals x squared minus 4x plus 3. Okay, so the first thing I'm going to do at point x equals 4. So plug in 4 in for x. Okay, then I get 16 minus 16 plus 3. Oh, well, that's easy. So that equals 3. Okay, so we know our point is equal to 4, 3. All right. And now I want to find the slope, right? So the slope is going to be equal to, let's take the derivative. So we get 2x minus 4 is my derivative function. And we're going to plug in 4 in for x. So I get 2 times 4 minus 4. So I'm going to get 8 minus 4, which is 4. So that means my slope equals 4. So if the slope of the function at this point is 4, then we know the normal slope is equal to negative 1/4. Okay. Now we're going to use what we learned in the previous two sections, where we have y minus y1 over x minus x1 equals our slope, and now we're going to write negative 1/4 instead of 4, and instead of y1 and x1, we're going to put in a 4 and a 3, just like we did on the previous two sections. And then we get we get y minus 3 over x minus 4 equals negative 1/4. Okay, now if I see something like this, you might think, okay, let's maybe cross multiply here. So this times this equals that times that. And then I would get, or maybe instead of cross multiplying, let's just multiply x minus 4 on both sides of the equation. X minus 4, x minus 4. Let's just do that. That crosses that out, and then I end up with y minus 3 equals negative 1/4 times x minus 4. Okay, because we're trying to solve for y anyways, right? So So then I do distributive property with the negative 1/4. Y minus 3 equals negative 1/4 x plus 1. And then the final step is we're going to add 3 on both sides. And then we get y equals negative 1/4 x plus 4. And that is the equation of the normal of the line. Let's do another example. Okay, so find the coordinates of the point where the normal to y equals x squared minus 3 at 1, negative 2 meets the curve again. Okay, we're going to be using technology to help us with this. Okay, so we already know the point is 1, negative 2, right? So we first need to find the derivative. So y prime is equal to 2x, and then the negative 3 just goes away. Okay, so if I plug in, what do we plug in for x? Plug in 1. So if I plug in 1, then we know that the slope, when my function is 1, is going to be equal to 2, because 2 times 1 is 2, right? So this means that the normal slope is equal to negative the reciprocal of this. Okay, and then we're going to do like we just did on the previous example, y minus y1 over x minus x1 is equal to, on our slope, we're going to use this, negative 1/2. Okay, and instead of y1 and x1, we're going to use 1 and negative 2. Okay, so let's do that. So now I've got y minus negative 2 over x minus 1 is equal to negative 1/2. Okay. Now, in the previous example, we multiplied both sides of the equation by x minus 1. Let's do that again to make that cancel out. And now I've got minus negative, so that's really y plus, right? Plus 2 equals negative 1/2 x. Negative times negative 1 is going to give me positive 1/2. Okay, so that is our equation of, oh wait, we're not done. I gotta subtract 2 on both sides. So if I subtract 2 on both sides, then I get y equals negative 1/2 x minus 1/2. I'm going to just write 1.5. We're going to have to use a calculator in just a minute. So we've got 2 equations we're going to type in the calculator. This is our normal equation. Right, we've got our normal equation, and we've got our curve, which is y equals x squared minus 3. So let's type both of those into our calculator. Okay. So if I take out my calculator, let's type them in. All right. X squared minus 3. Okay, and then the other one is negative 1/2, I'm going to write 0.5 x minus 1.5, and we're going to graph both of those. Okay, I'm going to change the window just so it looks zoom 6. Okay. So if the scale on here was the same on the x and this is my normal right there. So basically my graph that we've just drawn looks like this. And this line right here is our normal. And this is perpendicular to the tangent. So the pink line there is the normal, and this point right there is at 1, -2. So we're trying to figure out this other point right here. So in order to figure that out, we need to figure out the intersection, right? So how do we figure out intersection? Well, just like we did on the previous example, we're going to do second trace, second trace, and then we're going to choose 5 for intersect. Right? And then it says first curve, and it lists one of the equations. So notice how it's blinking over here. I need to arrow to the left to get close to this extra point, right? So it says first curve, I hit enter. I hit second curve, it's got the other function, it's close to this guy here, I hit enter. It says guess, we hit enter again, and here is the coordinate. This coordinate is -1.5, comma, -0.75. Okay, so what were the steps? We should write them down. It said first curve, then we did the arrow close to it, use the arrow to move it, then we hit enter, then it said second curve, then we hit enter again because it was already close to the dot, and then it said guess, we hit enter, and then we got the coordinates that you see there. All right, good luck, Mustangs.